Hello folks, we are coming with the next video now. We have already finished the problem number 9 and 10. Now we are taking the problem number 11. It's a simple problem. Let's see what the problem reads. The problem says that a particle moves along a curve 6y equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. That I have told you that these kind of wordings, you have to read the wordings, and from the wordings you have to check what they are telling. So first thing that they tell us is that the particle is moving along a curve 6y equal to x cube plus 2. First thing that they give is this. Then the other thing that's given in the question is that the y coordinate is changing 8 times as fast as the x coordinate. Now one needs to understand what they try to tell here. Y coordinate is changing 8 times as fast as the x coordinate means they are basically telling the rate of change of y and the rate of change, the relation between rate of change of y and rate of change of x. So basically they are trying to tell us that dy by dt is 8 times dx by dt. This is what is given to us. Now with the help of this, we have to find out. Now this doesn't happen everywhere. It happens only at a certain point. That the y coordinate is changing 8 times as fast as the x coordinate happens only at certain points on this curve. It is for us to find out at what point this happens. So that's what we are supposed to do. So let's find. All this time we used to, they used to give us a point r equal to so much. Find out, that way. It's just the opposite now. They give us a condition and they ask us to find out at what point this happens. So let's gradually do it. Since you already have this equation, obviously we have no other choice than finding the derivative and then checking how this can be used. So you can have it, we can start from there here. 6y equal to x cube plus 2 is from where you're starting. You're taking the derivative with respect to t on both sides. So derivative of 6y, 6 goes out. Derivative of y with respect to t is dy by dt. X cube, the derivative is 3x squared with respect to x. But because we are using with respect to t, so it will be dx by dt. And then 2, of course, because it's a number, there's no derivative. Now we all know that dy by dt is 8 times dx by dt. So let's make that substitution. This is 8 times dx by dt. So that helps us to kind of cancel both these, right? And let's see, therefore, what is x squared? X squared is 6 into 8 by 3. The 3 can go on the other side. Now this 3 can cancel here 2 times, and you're getting x squared as 16. 8 to the 16, like that x, the root will become plus or minus 4. The x squared being 16, x will be plus or minus 4. That's all. So they have just asked us a point, at what points this happens. So it happens at the point x equal to 4 and x equal to minus 4. Now because a point as such, you cannot just give the x coordinate, it's not complete. So you have to find out their y coordinates also and complete the points. And that's going to be your answer. It's only that much. So first, now for x equal to 4, let's find out the y value. See, y we already have. Y is x cube plus 2 by 2 if you want. So by 6, sorry. So let's check what it is. So x cube means 4 cube plus 2 by 6. 4 cube, 16, 64. Yeah, 64 plus 2 by 6. 66 by 6. That's 11. So y coordinate is 11. So also if x is minus 4. Same way, what is y going to be? X cube plus 2 by 6. So that way it is 64. Oh, it's minus 4. So it's minus 64. Minus 4 into minus 4 into minus 4. Minus 64. Plus 2 by 6, which is minus 62 by 6. If you want to get just cut by 2, 2, 31 times 2, 3 times. So it is minus 31 by 3. That's all. So the required points are first one, with 4 it is 11, and with minus 4 it is minus 31 by 3. That's it. They just asked us to find out the points, and these are the points, right? So that's about our problem number uh, 11, we can move to problem number 12 now. Let's see what the problem number 12 says. It says that the radius of an air bubble is increasing at the rate of half centimeter per second. At what rate is the volume increasing when the radius is 1? And it's quite simple. No? Air bubble is always spherical. We all know that air bubble is spherical. So let's see now how that is. They give us the radius. They tell us that the radius is 1 centimeter, and they tell us that the radius is increasing at the rate of half centimeter per second. They ask us to find out volume, the rate of change of volume. We all know for a bubble whose radius is r, volume is v, it can be given as v equal to 4 by 3 pi r cube. So therefore we have volume is 4 by 3 pi r cube. Obviously we have to find the derivative with respect to t. So let's take the derivative with respect to t, dv by dt. Here 4 by 3 pi is a constant. Derivative of r cube we all know is 3r squared with respect to r. Then because it is with respect to t, so you'll have to write dr by dt. 3 cancel. So what does it come to? 4 pi r for us is 1 and dr by dt is half. It's only that much. So 2 pi centimeter cube per second. The answer is 2 pi centimeter cube per second. That's about it. So that's probably how you get this values over here. For the next problem, probably we could meet in the next video. Thank you.